Okay, good afternoon. Good afternoon, everyone. My name is Alyssa Cherbu, and on behalf of Enersource, Hydro Mississauga, Hydro One Brampton, and partners in Project Green, I would like to welcome you to today's webinar. Before we start the webinar, I would like to run through a few logistics for the webinar. Note that your lines have been muted. Please type your questions in the chat section as we go along, and they will be answered at the very end of the presentation. If you come across any issues throughout the webinar, please send a direct message to me, TRCA host, within the chat section. So let's begin.
Good afternoon, everyone. My name is Jennifer Tays, and I am the Project Manager for Communications and Engagement for Partners in Project Green. So to start, I just would like to give you a brief introduction to who Partners in Project Green is and what we do, and then we'll go into conservation demand management from the saveONenergy side, and then we'll jump right into the main section of our presentation with Chris Beaver, who is the from Sheridan College, and he'll be talking about the audit funding overview, and he'll be presenting a case study. And it's been reestablished, so we're ready to go. My apologies for that. So Partners in Project Green really helps businesses in the Pearson Eco Business Zone unlock their collaborative advantage and extract maximum value from sustainability excellence. We do this in a number of ways. One, by providing knowledge through sessions like today's, where we talk about new and effective programs to assist you in your sustainability programming. We also have a number of opportunities to connect with different members of the community to really leverage the network that is Partners in Project Green and access the knowledge and the human capital that is here in the region to help drive sustainability forward, both at the individual businesses that we serve and in the community as a whole. So I'd like to say thank you to Enersource Hydro Mississauga and Hydro One Brampton, who have brought you this webinar today. Enersource Hydro Mississauga is a diversified electricity distribution and energy services company focusing on quality of service through innovation and operational excellence, delivery of conservation programs, and smart metering solutions. They serve over 200,000 homes and businesses. Hydro One Brampton is responsible for the safe and reliable delivery of electricity to their customers and continuing to accommodate new development within their service area. They deliver service to more than 14,000 homes, or 140,000 homes and businesses in the city of Brampton. Through these webinars, we hope to bring the latest technologies, programs, and tools to the comfort of your office while providing a format to ask questions that will help you discover the right solutions for your operations. Enersource Hydro Mississauga, Hydro One Brampton, and Partners in Project Green offer many resources to help companies along their journey to sustainability, and I encourage you to visit our websites or get in touch with us after the webinar to learn more about our programs, trainings, and events. This afternoon, we are exploring the topic of audit funding. Energy audits can help your business assess the potential for energy savings through technological and operational improvements. To introduce the saveONenergy programs, please welcome Janice Hodgson, Energy Service Advisor at Hydro One Brampton. Janice has just under 10 years in her role, where she acts as Key Account Manager to Brampton's largest users. Through the years, Janice has worked closely with key accounts and commercial and industrial customers to reduce their electrical consumption, improve power quality, and obtain incentive grants through third tranche funding and now Ontario Power Authority funding for equipment and process retrofits. welcome Janice.
Good afternoon. Thanks, Jennifer. Good afternoon to everybody. So I'm just going to give a quick rundown of the conservation programs that are available right now. So these are provincial-wide programs, which I'm sure many of you are aware of and are familiar with. So the provincial-wide programs are funded by the Ontario Power Authority, and each utility in the province then administers the programs and promotes them. And we also have pretty sophisticated targets to reach as well in terms of conservation for demand and consumption. So just to go through a few of the programs here, direct lighting install, which is also known as the Small Business Lighting Program. This program offers up to $1,500 worth of lighting retrofits, and it's a complete turnkey. If your business is under 50 kilowatts per month on average, then you would qualify for this program. So it's no out-of-pocket money that you have to pay for. You just sign up for the program, and as many lights that you can replace to more energy-efficient lighting, up to the $1,500 will be that work will also be completed for you. New construction high performance is a program that's offered for new construction. So this program is much like the retrofit program, which is our most popular program, but there are a few ways to apply for funding. But basically, any designs that you make above building code, you'll be offered different levels of an incentive for the kilowatt hours saved. So, for example, if you're 25% above the building code in terms of putting in more energy efficient equipment than the minimum that is required through the building code, then you'll receive up to $400 per kilowatt or 5 cents per kilowatt hour. And if you're between 25 to 50% above code, it's $600 per kilowatt and 7 cents per kilowatt hour. And if you go above 50% above code, then the incentives are higher, $800 per kilowatt or 10 cents per kilowatt hour. The Energy Audit initiative, I believe, is the one that Chris is going to be going through in great detail. So I'll just skip to the electricity retrofit incentive initiative, or on the website you would see it as the retrofit program. And that's on the saveONenergy website, so saveONenergy.ca. The retrofit program offers a variety of incentives to match whatever equipment or processes or equipment that you're replacing to upgrade to more energy efficient equipment. So there is prescriptive type of incentives that offers a dollar amount per type of piece of equipment, or there are also incentives available, which are $800 per kilowatt of reduction for non-lighting retrofit projects, or 10 cents per kilowatt hour of the annual savings, and that's up to a maximum of 50% of the total project cost. So there are some very lucrative incentives, and hopefully some of you listening in today have already taken advantage and gotten an incentive checks. And these programs were designed to end at the end of 2014. However, they will still be offered until 2020. There may just be a different way of applying, and additional programs will also be introduced next year as well. The Process and System Upgrade Initiative includes a few different categories, and I believe Chris will be going into a little bit more detail with that as well. But just to give you an idea, if you're doing a larger process upgrade that you're replacing a number of pieces of different equipment, or say for an example, a complete chiller retrofit where you're doing BSDs and the whole process, then you can apply for up to 70% of the total project cost. So there's a little bit more of a detailed analysis and review done with that, but it offers a larger incentive. There is within that program monitoring and targeting program. So this you can install and use complete monitoring system to monitor your kilowatts and kilowatt hour consumption and get some incentives back for that. And you can also get funding just for doing the studies of a study to see if something would be a good project to go ahead with and that you're going to have savings with. So you can get incentives there for that. And the demand response program right now is offered that you could get a monetary incentive for reducing your kilowatt demand between 12 p.m. And 9 p.m. on business days during the summer months, because that is the peak demand times for our province, and between 4 p.m. and 9 p.m. In the non-summer months. So you would work with one of the service providers that provides the demand response, and there's no penalty if you don't reduce the number of kilowatts that you commit to, but so that's a whole building reduction of kilowatts. So that's a quick rundown of all of the programs, and if you're a Brampton business and you have any ideas or you're already started and going ahead with any projects that you know or that you're installing more energy efficient equipment or doing some upgrades in any area, give us a call, and my phone number is on the screen here and my email address, and we'll help you, step you through the process of the applying for incentives and help you cater or put your project into the proper incentives and maximize the funding that's available through the Ontario Power Authority. So thanks for your time.
Thank you very much, Janice. And for all of you who are in the Brampton area, I encourage you to follow up with Janice. But please note, if you're not in the Brampton area, those saveONenergy programs are offered province-wide. So just get in contact with your local distribution company, and they will help you gain access to all of those programs. Again, the website is saveONenergy.ca. So we are very fortunate to have our speaker, Chris Beaver, here from the Center of Advanced Manufacturing and Design Technology at the Sheridan Institute of Technology and Advanced Learning. Chris is a senior business consultant with a proven track record and a demonstrated leader with over 25 years of experience in power generation, energy conservation technology assessment, and commercialization and energy management consulting services. Please welcome Chris.
Good afternoon, everybody. Thank you for taking time out of your busy day to spend it with us. Let me just see if I can get to a full screen here. Bear with me, sorry. Okay. There we go. So thank you for joining us, and thank you for the invitation from Hydro One Brampton and Enersource and partners in Project Green. We feel very fortunate to be working with this group of really qualified and very helpful people. We have a lot of information to go through, so let's get started. So our agenda today, we'll be talking a little bit about recognition to our funders and partners, who I must say have been incredibly supportive to Sheridan College and are making real-world applications available for our students, faculty, and staff. We're going to talk about why should we do an energy assessment, what types of energy assessments are there, what is the process. We'll take you through step by step. Give you a brief view of some typical findings that we come across, and then what do we do after the assessment. We'll briefly review incentives, projects, and the metering and verification plan, and then the second part will be an actual real-life case study analysis from a very large company, Magna Plascoat, located in Brampton. So here are our partners, and thank each and every one of them. Without their support, we would not be able to offer the quality of training that we do to our students. So thank you. So I'm with the School of Mechanical, Electrical Engineering and Technology. We're called MEET, or ME²T, which is part of the Faculty of Applied Science and Technology. So we're fast MEET at the end of the day. We provide engineering education, applied research, co-curricular activities, which means field activities, and we have quite some sophisticated laboratories and facilities, including a renewable energy lab, and the largest 3D printing capability in the country so far. So what we try and do at MEET is try to be a bridge between industry, academia, government, and professional societies. So that way we can leverage our resources and intersect with the government. And the main goal here is to help our industrial partners be more competitively positioned in the domestic and international markets. This is where we live. On top of the roof, you can't see it. This is an earlier picture, but we have a model of an advanced pump storage project, and we also have solar panels on the roof, and the lab is downstairs underneath. This is one of the newer buildings at the Sheridan campus in Brampton, and we're rapidly expanding. We're just about to build another skills center of over a 250,000 square feet directly opposite to this building. So this is the home for the Center for Advanced Manufacturing Design Technologies. So why should we be considering energy assessments? In our experience, and we've dealt with over 200 clients now, although the environment is important, it always boils down to I'm receiving very expensive utility bills, and they're increasing all the time and cutting into our operations, and what can we do about it? Of course, the environment is important. People believe there is a cost advantage. They understand that there is energy wastage going on. Employees want to get involved and are asking questions. There's some rumblings and hearing about financial incentives. Could be part of a larger organization where you're a supplier to a multinational where supply chain pressure is forcing you into being able to document greenhouse gas reductions and energy management. We decided to start doing this 5 years ago because we needed a way to be able to work with industry to make a connection for our students. And the idea we came up with is if we could go out into the field and help our local businesses save money, then they would be more open to working with us and our students. So our customers appreciate this. There's a downside risk on utility prices, and people would just like to know how much we spend and gain control. We've been to a number of plants where we asked the question, how much does it cost in energy to produce this part? And most often we're not able to get an answer to that. We take a holistic view of what's going on. So we look at the entire building, starting from the grounds outside, working our way in and addressing every system. What should the company do? In the time available, the most important suggestion that we can make is you must have your management's complete commitment and support. And that support and commitment must be communicated down to the employees of the company. This is a team effort, and the success of the projects that are identified are going to be a direct result of the collaboration and cooperation between the employees and management. So the company can do this, or we can be asked to do this, or your local distribution company can help you with this. But you need to start off by looking at how much energy we're using, what kind of targets should we set. Avoid one-off projects. Everything is interrelated. Build a portfolio to support these projects. Sell the portfolio to your management, and then move on with the implementation with the strategic use of incentives to improve the payback period. You have to have a plan, and you have to be committed to that plan. If you don't have a plan, let's get started. So, Sheridan follows the ASHRAE standards. That's the American Society of Heating, Refrigeration, and Air Conditioning Engineers, which is a North American standard which will define what kind of energy assessment that we're doing. And notice we're using the word energy assessment instead of energy audit, which is now being suggested by ASHRAE so that we don't scare people away. There are 5 levels of ASHRAE audits. We'll be talking about 3. The first level, as you can see, is really a preliminary end-use analysis, and I'll explain a little bit more about that. We'll end up calculating what the energy use is per square foot so that we can come up with an energy utilization index, and we can compare that to similar businesses around the world to give our customers a feeling for where do they stand. So it's basically a walkthrough, rough costs and savings for energy efficiency measures, and identify capital projects. Level 2 would start if the level 1 identifies sufficient opportunities to proceed. Level 2 energy assessment would be a more detailed survey and analysis, complete with an end-use breakdown, detailed analysis of all of the major energy consumers, cost and saving calculations for the energy efficiency measures. So this is important. We identify the measure, we identify the cost, we identify the savings, and then we're able to work out a simple payback calculation which helps sell the portfolio to management. And then we point our customers to low-cost, no-cost opportunities, which are usually in the operation and maintenance of the facilities, i.e. turn the lights off when not required. Level 2 then identifies more sophisticated projects with complex systems that may require further engineering analysis. We will then move to a level 3, which is a detailed survey and analysis, complete with potentially a 3D energy modeling and metering and verification. And this is at an investment grade level, so you can certainly take it to your finance department or a bank to look at the benefits of proceeding with the project. So before we start, we do a preliminary energy analysis before we go on site. So we need 12 months minimum of utility data, and that allows us to get a quick snapshot of what is the facility doing. And we can identify gross anomalies from this type of information. So we're a little bit prepared when we go in. We're looking for typical profiles for winter, summer, and both shoulder months for both electricity and gas. The ASHRAE Level 1, as mentioned, was a high-level view of the operations, and it provides generalized suggestions for energy and cost savings. And ASHRAE Level 2 actually gets into more detail, evaluating the building and process energy systems in a lot more detail. This will identify opportunities for energy conservation measures, which we will then perform the savings calculation on energy, the cost of implementing the measure, the incentives that are available, and work out what is the payback on the measures. So this allows the clients of this type of a report to prioritize which type of projects they would like to start with first. And usually we start with the projects that have the highest rate of return, with the lowest investment and the fastest results. ASHRAE Level 3 now is an investment grade study of the benefits, costs, and performance. And we use this for complex systems in larger industrial operations such as car plants, etc. But it can also be used in the commercial sector and also in the multi-urban residential sector as well. This may include 3D energy modeling, which we do with software provided to us through the National Renewable Energy Labs in the United States, and we also use Red Screen from Natural Resources Canada. Now, before anything can start, we must get our local distribution company's approval. We can start without their approval, but we risk not being eligible for the incentive. So step one is to complete the audit funding application and have it submitted to the local distribution company for approval. And once that is approved, we can get started with no risk of not being defined as eligible later on. We would ask for historical utility data and do the analysis as we previously discussed, a preliminary energy utilization. We need a floor plan of the facility to scale if possible, and we'll need a little bit more information as well. Just very quickly give you a quick idea of the cost. These are incredibly generous incentives. It's 10 cents for the first 30,000 square feet and 5 cents thereafter, up to a maximum of $25,000 or 470,000 square feet. So that is typically, from a Sheridan point of view, Sheridan provides level 1, 2, and 3 assessments, and this would represent about half of our cost as we work on a cost recovery basis. So the cost to the owner of the building is incredibly reasonable for the type of information they're getting. For leased facilities, the incentives are a little bit less, but what we found is that the owner of the leased facility typically gets involved to maximize the incentives and understands the improvements to their investment. So what happens? How do we start off? We've received the energy bills. We've done our analysis. We've arranged for a visit. We come in and we introduce our team. Our team is made up of research associates, aka students, faculty, which are qualified CETs, CEMs, or PEngs, and faculty, which are also engineers. One of the most important things that we do in this meeting is we discuss safety procedures. So safety is always number one for the visitors, and we have to understand the operations and how that building is actually being used. So you can imagine us going into a 3 million square foot car plant with lots of robotic vehicles running around everywhere. There's actually a 2-day safety course required for us. And then we'll review the agenda for the day. So come on in, we're open, and let's have a discussion. We'll do a preliminary walkthrough, looking at the operations and layout. We'll look at the major energy systems, lighting, heating, cooling, and processes. We'll have an internal discussion about potential problem areas, and then we'll sit down and have a talk with the plant, facility, and personnel to clarify our observations and make sure we are understanding properly what we're looking for. Once we've had that little chat and we've confirmed some of our suspicions, then we go on to a much closer inspection of the key systems. We'll start documenting the energy of the consummation of the equipment. We'll do that both by nameplate and engineering calculations and also by metering. Once we have that information all on the same day, we'll go back to the plant and facility personnel and now talk about those key findings and what our potential recommendations would be and see what their position and support for that actually is. Once we've done this level 1 walkabout, we're then able to provide an assessment report. And this comes in 3 versions, and we don't have time to really go through all 3, but I will be doing a case study, which is an ASHRAE level 2. So the assessment process and the report provides us with what is the energy consumption, what are the primary end uses of the consumption, what opportunities have been identified to save, and provide technical and cost analysis of the recommended retrofit measures. We'll then look to see which incentives are applicable to help the payback period, and we'll be moving on to next steps. So in the debriefing on that first day's visit, we'll discuss the opportunities with the plant management and operational personnel. We'll identify what we call the low, no cost or immediate savings opportunities that they can implement before waiting for anything else, and those usually are found in the operational and maintenance of the building. And we'll also identify measures that may require level 2 or level 3 engineering analysis to be able to provide them with confident numbers. So post-audit phase, we've collected the data, we start analyzing the data, we complete that analysis, and we make recommendations including simple payback calculations for energy management opportunities. We'll draft the ASHRAE Level 2 report and present it informally to the client. We'll also provide it to the local distribution company for approval, and the approval then would allow the incentive payment to pay for the audit funding to go directly to the client. And at the bottom, I've just reviewed again quickly what the costs are to do a ASHRAE Level 2. The assessment report looks at consumption and uses, opportunities to save, retrofit measures, applicable incentives, cost-benefit analysis, including a simple payback, and we make a recommendation to proceed immediately with low or no-cost energy management opportunities. Short payback, high-return projects, and ASHRAE Level 2 assessments for larger complex opportunities are then the next steps. So what do we typically identify? What we can see here is a motor in your left upper corner. You see a thermal camera taking a look at a building envelope, infiltration, exfiltration. We see compressor tanks. We see a very poorly lit facility. The lower left-hand corner, if you can recognize it, are actually battery chargers for forklift trucks. So at the end of the shift, typically a company plugs in 10 forklift trucks and have set their new peak for the day. An example of a thermographic picture in the lower right-hand corner, and this is an awful lot of our work, is rooftop units or hair handlers, which are doing the heating, ventilation, and air conditioning for the building. This particular roof has over 110 rooftop units, with the smallest one being 10 tons. So we've delivered the report. We've gone over the report. We have a follow-up meeting. It's been submitted to the local distribution company. What's next? Well, let's identify the projects together and work together and get it done. And that really should start with developing an energy management plan, if we remember the holistic review, including a metering and verification plan. So Janice gave us these links before, and I understand that Partners in Project Green is going to make this presentation available for those who ask for it. So all this information will be available upon request. And of course, you can contact your local distribution company, Partners in Project Green, or Sheridan College. There's quite an array of incentive programs. Janice touched on some of them, but you can see here there are quite a few. Process and systems, monitoring and targeting. You can actually have your own energy manager, which is subsidized, his salary or her salary is subsidized by the Ontario Power Authority. You can work with your key account manager. There's equipment replacement. And I'm not going to read the entire slide for you, but you will see in the second column that there is incentives to cover the cost for level 1, 2, and 3 ASHRAE audits. Typically, we will do a level 1 audit at no cost. Once we've been into a project and we've done a retrofit, there are some key parameter measurements that we have to take. So in a lighting retrofit, obviously we have to know the operating hours and the occupant behavior. We take a Hippocratic oath insofar as we promise not to do any harm. If we don't see an opportunity or a good application, we'll come right out and say it. Retrofit isolation, another example would be the installation of variable speed drives and controls for pump flow. So here we need to take a baseline measurement before the installation of the variable speed drive and also take a measurement after the installation. So it's just like going on a diet. When you start your diet, you take your weight, and then you set your targets, and then you continually monitor your weight to see how the progress is going. We'll do whole facilities, and these require an energy management plan. And just to give you one example, a lighting retrofit is usually one of the first projects that the company would consider undertaking, and typically would receive either the prescriptive or engineered incentive. But we go a step further. We know that by changing the lighting, we've reduced the kilowatt load on that building, which is heat. So that means the air conditioning system and the compressors therein aren't going to have to work as hard as they did with all that heat in the building. So we can actually then do an engineered calculation and verify that through metering and verification, and obtain further incentives payments for the client on identifying these reduced kilowatts. So that's a simple example of a holistic approach. By affecting one energy system, you're most likely affecting another one. And for large capital projects, we can do very sophisticated, calibrated 3D simulations of the client's facility, and that allows us to do what-if calculations and also provide support for capital or operational budget decisions. So that sort of concludes the first part of our presentation. You can see my name and where to contact me. This is my energy team, and this is our associate dean. So hopefully without missing a beat, let's take a look at an actual ASHRAE Level 2 report. And we have the customer's permission to go through this. So we thank Magna International and Plascoat very much for their permission to do this. So this is an ASHRAE Level 2 energy report of their facility here in Brampton. They're making plastic automobile parts. This is our disclaimer on the report put in by the lawyers. And I believe this report will be made available in a sanitized version also upon request. So the areas we look at are covered in the table of contents, but I draw your attention to the fact that before we get into any details whatsoever, we go immediately to what is the energy utilization index of your facility, and what is the space, function, and system summary, and what are the opportunities for energy management savings. And then we start to go into a lot more detail on the building. So I'm going to focus on, not the whole report, but take you through some of the most important parts. So this report was done in 2012. We follow ASHRAE Research Project RP-669 and SP56. So these are procedures for commercial building energy audits, and also Natural Resources Canada Federal Building Initiative Audit Standard Guidelines. Immediately, right at the beginning of the report, sorry for that, we put up front for the customer, where are the energy conservation measures? This report's been modified a little bit. We've removed one column, which was the simple payback calculations, which is really proprietary information for the company. And they are ranked in order of return, simple payback, and the fastest to be able to realize results. And you can see in this particular case, we're looking at reducing their lighting load by 20%. We're looking at reducing their HID fixtures by up to 70%, which isn't trivial. So you're taking a 450-watt high-intensity discharge lamp high bay and replacing it with a 100-watt LED, which is providing more lumens, better coverage, a nicer light, and at about 1/10 of the cost, with about 10 times of the life expectancy of a standard T8 or T12. We've identified occupancy sensors, which take care of human nature's sometimes forgetfulness to turn off lights, etc. We will recommend in this particular case the installation of CO2 feedback to the makeup air units, so that we're not just pumping air all the time, it's being pumped in as required. We've done exploratory study on the effect of cooling tower upgrades, and there are some incredible advances in technology in being able to do chiller optimization analysis in as little as a day, up to 1 or 2 megawatt sized chillers. They're also making vast improvements on premium efficiency motors with built-in variable speed drives. So there's incredible savings to be made there. Water savings are also an energy user and environmentally important. So you need pumps to pump water. The less water you need, the less pumping you do, the less energy you use. And the less water you use, the less you pay for your water. I wish I could get this to go away. Let me see if I can do that. Good. Air compressors are an incredible opportunity for fast returns and low investment. General housekeeping, insulation of the facility, and investigation towards their electric forklift truss. And in that case, excuse me, we ended up putting in timers to avoid all the forklift trucks for creating a new peak. This particular plant had a fairly poor power factor correction, which again is a relatively easy problem to correct. And by correcting that, you're actually getting $1 worth of energy for every dollar you spend. So if you have a power factor of 80, you're only getting 80 cents worth of electricity for every dollar that you're spending. Not only that, it really hurts motors and other production equipment. So this is the 12 findings that we found on the very first analysis of this particular plant. And I can tell you that John Tallis from this particular plant is implementing each and every one of these measures, and was just telling us the other day that he's getting his budgets approved by senior management as they see the benefits of moving ahead. So the energy utilization index for this particular company is 350 kilobtus per square foot per year, and they have about 200,000 square feet. So you can see most of that is made up with electricity, and we could not find a comparable company in Canada to be able to make a comparison, but we were able to do comparison to U.S. plants of this kind. Then we start getting into the details. We have to understand the space function and how that building works, and we start identifying the major energy users. The building envelope is part of the energy picture, so we have to understand and analyze what type of building we're dealing with and what condition it's in. We've actually found buildings with holes in the wall which are large enough to put your arm through, and they're wondering why they have very expensive electricity and air conditioning bills. We have to determine whether it's leased or owned for the incentives, how many floors, et cetera, et cetera. How is this facility being used? In this case, it's predominantly used for the manufacture of plastic form automotive parts. They also have a warehouse. They have 350 employees, 100 of which work in the office area. They're 24 hours a day, 7 days a week. So this becomes a bit of a challenge for us to go in and do our work. We end up going in usually during the evening shift. And this schedule changes with the level of production within the plant, but this is their typical schedule. Types of major loads: compressed air is used extensively, vacuum and chiller systems, hundreds if not thousands of motors, induction molding machines, HVAC and ventilation, automated assembly lines, lighting, dryers, and miscellaneous plug loads, including tons of fans all over the plant floor to try and keep the employees comfortable. We look at the fenestration or the windows to see what kind of shape they're in and take some thermographic pictures. We will also do some preliminary envelope investigation, basically looking again for R factor, what's the insulation factor, and what are the opportunities to address infiltration and exfiltration on that building. We do a very detailed analysis on the electrical consumption on a minute-by-minute basis. And just a little footnote here that this particular facility has 2 meters, so therefore when we're doing the paperwork for incentives, we actually have to do 2 applications based on each meter number, which is associated to a different account number, but both in the same building. We get into some quite detailed numbers. You can see that they have a significant load, ranging about 3 megawatts to 3.5 megawatts. So they have a substantial electricity bill, something that really affects their profit margin. We can see some totals. We're talking in the millions of kilowatt hours and millions of dollars to be able to pay this bill. So this is going to represent really how this particular plant operates. And again, here we're looking for anomalies. Here we found a certain anomaly in May that requires further investigation. As it turns out, they got a very large pressing order, and most of this anomaly was actually explained. We're able to look at daily averages to make sure that there's nothing strange going on. And again, the same anomaly was picked up here, but it was explained. We look at the monthly load factor to see how straight a line it is and where is the load going. So here we have a load jumping between 80% down to 40%. And we'd like to be able to smooth that out as much as possible. Monthly power factor, for those of you who are not aware, there are two elements on your bill. You will pay for your kilowatt hours, and you will also pay for your kilowatt or your monthly peak. So for the highest continuous 3 5-minute periods anywhere during the month, that kilowatt reading is what you will be charged for the entire month for your peak load. So controlling peak is very important. So here the peak power factor was hovering above 90% consistently, and then we saw that there was a downturn. So we've actually gone in and addressed that. Here we talk about demand cost and energy cost. So you can see that the energy cost is the predominant portion of your bill, but demand cost is not a trivial portion either. So we must be able to control both. So think of energy as your odometer on the car that's counting the number of kilometers you're traveling, and think of demand cost or kilowatts as your speedometer, or how quickly am I spending that gasoline or electricity. So we go into a lot of detail, monthly energy and demand. We'll also then get into historical natural gas, and we work with the major natural gas suppliers in the province, and we'll come up with the same kind of information for their daily energy use. And this is for analysis purposes to compare to production processes to see where there may be something that could be improved. So here the natural gas usage is normalized against external temperature for 2 study periods, and we can see that in 2010-2011 there were some significant changes in the weather and how the building reacted to the weather outside. So a cost breakdown of monthly gas consumption. What are the other costs? And here we actually look at a detailed bill, and in some cases people are in locked-in contracts, and one of the first recommendations we would make is to get out of any locked-in contract for electricity or gas. Water is also very important, so we measure what the water usage and the energy usage related thereto, and we give a breakdown of the total energy use in the building in 2010. So that resulted in 70 million kilo-BTUs for both natural gas and electricity. We can see what the breakdown is here, predominantly electricity. So if you're the energy manager for your plant, where are you going to be spending most of your time? Energy performance summary. Here we're looking at the totals again and what the total cost is to give management a feeling for how significant this issue is. We will then do cost indices to give a little more information. And we're really breaking it down here in energy utilization terms per square foot per year. We'll do analysis of the metered electrical load, and then we'll start with our recommendations in detail. And I won't go through these recommendations in detail because we're just about out of time for this section, and I would either turn it over to the organizer or be open for questions at this point.
Yeah, cool. Thank you very much, Chris, for joining us. That was a really great overview on how businesses can access some support to push their sustainability agenda forward. I'd like to remind participants that the webinar was recorded and that we'll be sharing the recording and slides as well as an amended case study with you at a later point. So we do have some time for questions, so please feel free to enter your questions into the chat, but we have a few to start off with. The first question is, how much time does it take for your team to complete each level of audit? So level 1, 2, and 3, and how many sort of man-hours per month?
Very good question. So a level 1 typically in expended time, not calendar time, because there could be some time in between when we receive the bills and when we do the actual visit. But a typical preliminary energy analysis will take us a day. A walk around on the facility depends on the size of that facility. So obviously a large 3 million square foot facility will take us a number of days to do, whereas smaller ones could be only half a day. Our typical level 1 team consists of 1 faculty member, 1 staff member, and a minimum of 2 research associates, which are our students. A level 2 is a little more involved, so we cannot start until the Energy Audit funding application is being approved by the local distribution company, or we get their approval to start. And the analysis there typically will take a couple of days of the information that we've received, which we enter into our software for regressive statistical analysis and cost utilization indexation. And then we will assemble our audit team, which then is typically 2 faculty, 1 staff, and we try to go for 4 to 6 research associates, which, again, we're reminding people are students. So the time from receiving the approval of the application to when we would deliver the report can be in urgent situations as short as 2 weeks, but typically is between 30 to 45 to 60 days for the preliminary draft assessment. And then level 3s can actually take several months to complete, and the size of that team depends on the complexity and integration of the equipment that we are looking at. So I can't give you an actual breakdown of hours off the tip of my tongue, but I can give you an example where we did do a lighting assessment on a 3 million square foot auto manufacturing facility in 3 days with a team of almost 20 people. So Sheridan has a bit of a advantage insofar as our labor pool of trained research associates or students is quite large, and we're able to take on very large projects or take on a range of a lot of very small projects. Hopefully that answers your question.
Cool, thanks, Chris. So we have another one here. How do you decide whether to go with retrofit audits or PSUI PES for water and wastewater facilities?
I didn't hear the second part of that question. The first part I heard was, how do we decide between an energy audit and?
So it's a retrofit audit or PSUI PES for water and wastewater facilities.
I'm not actually familiar with what a PES analysis for wastewater facilities are. I would have to defer to my colleague, John Linsagisi, who's our environmental specialist there. But what has happened in our energy audits is typically if there was a water issue identified.
Oh, just a clarification. It's a preliminary engineering study.
Okay. Under what standard, I'm not sure that preliminary engineering study is done, but it sounds very much like a ASHRAE Level 1 energy assessment, where one goes in and identifies the major energy consumers and water usages, and then makes a recommendation whether the findings warrant any further investigation, or if there are some savings available that could be identified, documented, and implemented. So really the walkabout is your initial assessment to determine whether we want to go any farther. And that's, of course, made in conjunction with the client.
Okay, perfect. I'll put the person who answered or asked that question in touch with someone on your end, and we'll move ahead with the next question, which is, will these programs be available in 2015? And I'd also going to open this up to Janice, so just hold on with me for 1 second. Yeah, so Janice, you've been unmuted. Can you speak to whether these programs will be available in 2015?
Yes, they definitely will be. So all of the utilities will be in a transition phase throughout 2015. However, the main base programs are still all on the list to go ahead from January until May, they will January until May, and then each utility is going to just kind of cater the program. So it's hard to predict if you're in Mississauga or Brampton exactly how this incentive will work out, but I think that either way, the electricity retrofit initiative is still going to be available the same way. The process and systems is still available. Audit funding is still available. So yeah, there's definitely a lot of funding available, and it's just best to get your projects in sooner than later. If you say, for example, if it's a T8, some things might the T8s might be phased out a little bit because T8s are coming to be the standard, but yeah, there's still going to be incentives available all the way until 2020. So,
a general comment, if I may. I serve on a number of committees with the OPA and the Independent Electricity System Operator, and it's becoming pretty clear that the policy of the newly re-elected Liberal government is to increase and put a large emphasis on conservation and demand management measures versus the older approach of their FIT programs, which are under a total reanalysis. So if anything, between now and 2020, I think we'll be seeing either the incentive numbers being maintained or increased, and they're working very hard to simplify the application procedures.
That's right. So they're not going anywhere, that's for sure.
Okay, awesome. Thanks very much. So we actually have one more question, but I realize it's 2 p.m., so if you need to exit the line, then thank you for joining. But the final question is for Chris. So why would you normalize to kilowatt BTU instead of the kilowatt?
That's a very good question. The scenario we find ourselves in is dealing with different types of energy. So natural gas is measured in meters cubed and BTUs per meter cubed. Electricity is measured in both kilowatts and kilowatt hours. And what we need to do is to come up with an apples-to-apples comparison. So we just make some simple transformations of numbers or change them to a common denominator. So we'll take our kilowatts and convert it to BTUs, and we'll take our kilojoules and convert it to BTUs, and that way it makes it easier for the customer to understand how these apples and oranges have been blended together. We can actually present this in any format that the client requests. We've just found that this is typically the easiest to understand.
Can you just say why you chose the imperial system, or why the imperial system is used to normalize instead of the metric system?
That is, in this particular case, was a request of the client, and indeed, ASHRAE standards are based on U.S. imperial systems, so that makes it a little bit easier for us to do that. We have no difficulty whatsoever operating in metrics, and a lot of our reports are actually metric.
Okay, awesome. Thanks. Thanks very much, Chris, for joining us. And on behalf of Enersource, Hydro Mississauga, Hydro One Brampton, and Partners in Project Green, we thank you for joining us this afternoon. And a reminder to visit saveONenergy.ca or contact your local utility provider to gain access to these incentives. You can also get in touch with us, and we can put you in touch with anybody you've heard from today. So thanks again for joining us this afternoon, and have a great rest of the day.
Thank you, Alyssa.
Thanks.